Good afternoon, everyone. So, today we are going to cover some basics of hypothesis testing and a very few example which will help you to understand the complete module, I believe. So, let's start with the first question, which says that 10% of circuit boards were defective, and an engineer suggested a change in production process in the belief that it will result in a reduced defective rate. Find H naught and H alpha. So let's try to understand how do you identify H naught and H alpha and how they are defined. So what we have seen previously is that the idea is that we have an unknown parameter and it has some confidence interval. So that value of theta lies in some interval. If you partition this interval into two subsets, then there are two possibilities: either theta belongs to one subset or the other subset. So if we we take a hypothesis that theta belongs to first subset, so we call it H naught, and if belongs to the second subset, we call it HA. And of course theta must belongs to one of the two subsets. So at a time only one of them is true, one of the hypothesis, either H naught or HA. H naught is null hypothesis, HA is alternative hypothesis. But how do we know which one is null, which one is alternative? So HA referred to researcher's hypothesis, which means that something we want to validate, and H naught means which is already there. So there are two things: you have already some information and some information you want to validate. So H naught is you already have some information, and HA is you want to validate. Now if you see this question, before that, remember, when you talk of H naught and HA, it revolves around the unknown parameter theta. So it means that you need to define it in terms of the parameter. Now what information you have? 10% of circuit boards were defective. So what is H naught? So if P is a parameter, which is probability, then H naught is P is equal to 0.1. And what is HA? HA, that engineer has suggested a change in production process in the belief that it will result in a reduced defective rate. So reduced defective rate, it means probability should be less than 0.1. So this is how you identify H naught and HA. Now once you identify, then there are two errors which are associated with H naught and HA. First one is type 1 error, which says that probability to reject H naught when you know that it is true. So it's true, but you are rejecting it, so it's an error. And the type 2 error is exactly the reverse of type 1, which means you know that HA is not true, H naught is not true, but you accept it. So in one case you reject H naught, in the other case you accept H naught, and you compute its probability when the converse is true. So let's see one more example. A politician claimed that he will gain 50% of votes and thereby he will win. But an expert think he will lose the election. So what would be H naught and H? So H naught means what politician thinks. Yes, because you have this information that he will gain 50% of vote. It means the probability is greater than equal to 0.5. And HA is probability is less than 0.5, because the expert says that after studied, so it is a research, which says he will lose the election. Now, to test their conjecture, the expert randomly select 15 voters and find why of them would vote for the candidate. Calculate the probability of type 1 error if rejection region is given as follows. So, the region or the interval where you reject H naught. So, first recall what is type 1 error and what need to be computed. The probability to reject H naught when it is true. It means you need to compute probability of y less than equal to 2. And what is y? Out of 15 candidate, the number of the candidate which vote in support, provided H naught is true. Now, to compute this probability, you need a distribution for y. What distribution follows? Which is clear, because out of 15, y of them vote for the candidate. So, it follows the binomial distribution where n is 15 and with probability p. How do you compute p when it is not given? So, there is a thumb rule which says that select p in H naught and it should be closest to HA. So, which clearly indicate even from here that p would be equal to 0.5. Now, when p would be equal to 0.5, you know y is binomial distribution. So, this can easily be computed. So, alpha comes out to be as follows. Now, try to compute type 2 error. So, let us assume that p is 0.3 and now calculate the probability that sample will lead us to conclude that H naught is true, and mistakenly it concluded. It means you accept H naught when it is not true. So, beta is the probability you accept H naught when it is not true. Now, rejection region was y is less than equal to 2. So, acceptance region is y is greater than equal to 2 when probability is 0.3. Again, you know y is binomial distribution. So, this probability can easily be computed. So, let us see the last question. As I told you, I am not going to discuss many. I am just introducing or help you to understand what is H naught, HA and type 1 and type 2 error. So, read the question. It says that a mixture to be used for grotting should have a strength of more than 1300. The mixture will not be used until experiment evidence, means research, indicates that this strength has been met. So, which means what is H alpha? What research is saying? That strength is greater than, strictly greater than 1300. Yes. Suppose compressive strength for specimen is normally distributed with sigma 60. Let mu denote the true average compressive strength. What are appropriate null and alternative hypothesis? So, HA we have already discussed, because it's the research which says that this strength should be greater than 1300, then only we use it, which means that your H naught is, says that mu should be equal to 1300. Okay. Now the next part asks that, yeah, this is one observation, that H naught always includes the statement of equality. So in HA you do not use equal to sign, it is only used in H naught. So H naught either can be mu is less than equal to 1300 or mu is equal to 1300. It cannot be less than, because when it is less than, then we cannot use it. So assumption is that it is 1300 when we use it, but research shows that it should be greater than 1300. Now let's read the next part, which says that x bar is sample average and n is 10. If x bar is 1340, should H naught be rejected using a significance level 0.0? So there is one more concept of the when do we reject H naught and when significance level is given. So the theory says that we reject H naught if p value is less than alpha, where alpha significance level here is 0.01. It means we do not reject H naught if p alpha is greater than equal to, p value is greater than equal to alpha. And what is p value? So it depends on the rejection region. So if rejection region is W less than equal to C, then P value is probability W less than equal to W naught when H naught is true. And similarly, so it means that what I need to compute is P value, and for the P value I need the rejection region. Okay, and for this probability I also need the distribution the capital X follows. So when X, it is already given that this strength is normally distributed, so X bar follows the normal distribution with mu and sigma by root n. Recall these concepts we have already discussed. So now the P value, so P value is when you reject H naught. So there are only two possibilities when X bar, so if X bar is 1340, so for rejecting it should be greater than 1340. Provided H naught is true. Yes, so again see that when we talk of the parameter, there are only two possibilities. So like mu is either 1300 or it is greater than 1300. So when you have to reject it, when X bar is 1340, if you have to reject it, it should be more than 1340. Now X bar is normally distributed with mu and sigma by root n. So probability of Z greater than equal to 1340 minus mu, which is 1300, divided by sigma, which is 16, divided by root n, which is 10. Now using the table, this probability can easily be computed. So there are many concepts, but again I am introducing it. You need to see many more exercises so that this would be more clear to you. So now this P value comes out to be 0.0174, which is greater than alpha. Therefore, we do not reject H naught. The last part says that for a test with alpha is equal to 0.01 and when mu is 1350, what is the probability that mixture will be just unsatisfactory? Type 2 error. So how do you compute the type 2 error? So type 2 error is defined as except h naught when HA is true. Now to accept h naught, we need the acceptance region for h naught. Now for alpha equal to 0.01, we have already seen how do we compute the rejection, the probability of rejection or p value. So the same procedure need to be computed, and we need to see that for what values h naught got rejected, which gives us the idea that for what values h naught would be accepted. So as we did in the previous case, alpha is defined as reject h naught when h naught is true. So p value is equal to alpha. If I compute this one, then it gives me x bar is greater than equal to x bar when h naught is true, and we have mu, we have sigma. Using all of this, we computed that x bar comes out to be 1344.21. It means that if x bar is greater than 1344, then this p value would be less than alpha. So for this value, we reject h naught. It means that if x bar is less than 1344.21, then we accept h naught. Okay, and now the probability can easily be computed. So you need to compute x bar less than 1344.21 when mu is equal to 1350. So x bar minus mu by sigma, you need to compute that probability, and that gives you the required answer. So again, I am telling you that I just introduced you the definition. You must follow the lecture slides now to see many more examples and many tests which has been discussed there, and I believe you would be able to understand the concept of hypothesis testing. Thank you.